All right, everybody, we're back for our second subsection within this field of biological and biosocial theory. Now, there are lots of different ways in which biology is at least hypothesized to interact with criminality. Okay? One of the more common is the idea that criminality is somehow linked to testosterone, right? That testosterone is kind of the male hormone. Both men and women have testosterone, but men have much more testosterone than women. And it's thought that maybe this increase in testosterone is the reason we see so much more crime among men than we do among women. So they've done test after test after test, and the vast majority of them find either no link or a very, very, very small, weak link between the amount of testosterone that a person has and their criminality. Very little kind of correlation there. So one of the more modern interpretations of this, or one of the more modern hypotheses that has still not been really adequately tested, is not necessarily about testosterone in the body during adolescence and puberty and then as a grown adult, but the amount of testosterone that a fetus gets while it's in utero, while it's still in the womb, right? And it's thought there's at least the idea, and some evidence, some research is being conducted about whether the amount of testosterone that a fetus kind of soaks in while it's in the womb may influence criminality. But that's something that still doesn't have a lot of evidence for it, at least not yet. Now, another thing we can talk about regarding biochemistry is gender. Now, we all learn in kind of elementary school biology that there are 2 chromosomes for gender on the human genome. There's the XX and there's the XY, right? And if you get the XX, you're a woman. And if you're XY, you're a man, right? Now, this is overly simplistic, as a lot of things that we learn in elementary school are, right? And what biology has shown since we've started testing lots and lots of people is that the vast majority of us get either XX or XY. But there is a small percentage that get other. And sometimes this results in kind of immediate death because it's not compatible with life. But a lot of other times, it expresses itself with almost no differences between somebody who might be XX or XY. So, and then there are some variations on this kind of XX, XY dichotomy that are somewhere in the middle, where it has relatively drastic physical, biological effects on the living person who is born with either not XX or XY. And as you can see from this chart above, there are lots of different kind of possibilities, right? You can get XX, you can get XY, you can get YY, you can get XYY, you can get XXX, you can get just X, right? And this is kind of interesting. It's relatively rare. Only like single digit percentages of people have one of these non-XX or XY chromosome pairs, or triplets, or single. But it's far more common than people thought 50, 60, 70 years ago, okay? And the variation that is most linked to criminality, at least in theory, or in, I guess I should say in hypothesis, is XYY, okay? And XYY individuals are born biologically looking the same way as somebody who is XY, right? So they look like boys when they're born. And in many cases, there have probably been thousands or millions of people throughout human history who have been XYY, and never knew it. Because the only real outward signs of being XYY versus just XY are extra height and larger hands, which is not really that much of a difference. But it's hypothesized that XYY males will have kind of more maleness, right? They'll be more male than male. And thus, they will be even more likely to be criminal than XY males. And the evidence here, there was some early evidence that showed that this might be true, but now the evidence is kind of showing no, it's not true, and XYY males aren't more likely to be criminals. And it's still kind of up in the air, but basically, if there is anything to this, there is the idea that gender is on a spectrum, right? And we've got male on one end and we've got female on the other end. And the XYY male would be even further down the male line or further on that male spectrum than even XY males. And criminality goes up based on that gender spectrum, right? So we've got XYY and then XY and then, you know, all these other different combinations of genetics, all these different combinations of, you know, XX and XY and just X and XXX. And all those different kind of combinations of gender and sex chromosomes get put at different places on this gender spectrum. And the idea is that as you get more towards the male end of the spectrum, that results in more criminality. And again, there's some evidence of this, but not a lot of evidence of this, and it's still kind of disputed. But one of the things that I find interesting about this kind of gender spectrum is that when it comes to trans people, it's not necessarily the gender that they're born as that most reflects their criminality, right? So trans men have criminality more like cis men, and trans women have criminality more like cis women. And so it is a very interesting factor in genetics and in criminality and in sociology and in lots of other fields about how this gender spectrum works and where kind of different genetic combinations wind up on this spectrum and how that directly translates or indirectly translates to criminality. Another factor in this in biochemistry is hormones. There are lots of different hormones in addition to just testosterone that could influence criminality, right? Kind of the old 1950s, well, maybe later than the 50s, more like 1980s, 90s stereotypes for women especially is the whole PMS, the premenstrual syndrome, hormone changes in women's bodies that is thought to make them angry and irritable and horrible to live with, you know, once a month, right about the time their menstrual cycle is arriving, right? So that was looked at as a possible explanation for crime among women specifically, right? And that's kind of weird and interesting and fascinating to me. But then there are also other hormones that seem to be connected to crime, at least in some way, right? Whether directly or indirectly or spuriously or whatever. Two of the hormones that have gotten the most attention are dopamine and serotonin, right? And these are kind of the happy drugs. You know, when you get right down to it, the only two things you have ever liked in your entire life are dopamine and serotonin. Because everything you do that brings you pleasure and joy and happiness, from eating chocolate to falling in love to winning the lottery, just come down to dopamine and serotonin in your brain, right? And it seems that criminality is related to dopamine and serotonin, but in a different fashion. With dopamine, criminals tend to have either very high or very low levels of dopamine. So there's a curvilinear relationship where criminality is high at one end and the other. But serotonin seems to have a negative relationship, i.e., as serotonin goes up, criminality goes down. So it's only those with very low levels of serotonin that have high levels of criminality. So this is all kind of interesting, how this kind of biochemistry and sex chromosomes and all those things interact with criminality. It's definitely something that kind of needs more research. But we're going to move on to neurophysiology. Okay, and this is where we kind of use the IQ test that we talked a little bit about before, and start looking at that under a more modern scientific lens of how this interacts with criminality. All right. Now, first off, early IQ proponents indicated or stated that IQ was unchangeable, but now we know that it is changeable, right? It is absolutely possible to increase or decrease somebody's measured IQ over time. How much we can change it is still a little bit up in the air, but it's definitely changeable, right? And there has always been a weak but consistent correlation with deviance, i.e., higher IQ individuals seem to commit less deviance than low IQ individuals. And this is a weak relationship. This is nowhere near predictive. But there does seem to be a small influence of IQ on deviance in adolescence. Now, there's been some research, if not a lot of research, that shows that this correlation disappears when you control for other factors. Right? Everything from social class to education to parenting style to social bonds to all kinds of other things, other factors that we're going to learn about in future sections when we talk about more modern theories of crime. Okay? The other question is this direct or indirect? In other words, is it kind of your intelligence itself that dictates whether you become a criminal or not? Or is it your intelligence that changes other factors about your life that then indicate whether you're a criminal or not? For instance, graduating from high school. Is it your intelligence that affects your high school dropout rate, which then affects your economic chances, which then affects your criminality? Right? So there's a big question about whether IQ actually directly affects criminality, or whether there's one or two or three or four steps between IQ and crime. Okay? The other question is, how long does it last, right? So does IQ measured when you're 15 might predict your deviance at 15 or even 16 or 17 years old, but it doesn't seem to predict criminality at 19 or 20 or 21 or 22 years old. So measuring somebody's IQ when they're an adolescent really only can tell you a lot about their adolescent deviance. It loses any weak predictive power it might have had as that person gets older. Okay? Now, another interesting factor of, interesting intersection of biology and criminality comes in the field of kind of the brain. Okay? The brain is the most complicated biological thing known to humankind. It is incredibly, incredibly complex, and we are only beginning to scratch the surface of understanding the human brain. Okay? But there are a few things we seem to have figured out. We haven't quite figured out why yet, but there are certain things we've kind of identified. One of those is that people who get brain injuries tend to increase their criminality. especially in kind of the frontal and parietal lobes. If you get a brain injury in either of those two areas, your criminality seems to increase. The real question that we haven't really answered yet is why? Why do brain injuries, especially in those areas, seem to increase crime? We don't know. There are a few different hypotheses, a few different ideas out there, but we don't know because the brain is just far too complex for us right now to really understand it in that level of detail. But another thing we've kind of found is there are different waves in the brain that we can measure using a electronic EKG machine, right? So we can measure all the electrical activity in people's brains. And there's different kinds of electrical signals going on in people's brains based on lots of different factors. When you're asleep, you have much different brain waves than when you're awake. When you're happy, you have different brain waves than when you're not. And all these different factors influence what kind of brain waves you have and how intense they are and all these different things, right? But one of the things we have measured and have kind of confirmed is that criminals seem to have a lower level of certain kinds of brain waves than non-criminals. And this ties into what's called the autonomic nervous system, right? And this is kind of the background biological processes that we don't have to think about, right? Breathing, heartbeat, default brain activity, even when we're not really doing anything. You know, all those things that our body does without us having to think about it is the autonomic nervous system, right? And criminals, in addition to the lower level of brain activity, also have lower, slower heartbeats, lower rates of respiration, right? So their autonomic nervous systems seem to be operating more slowly and with less intensity in its kind of default resting state, right? So one of the ideas here is that criminals become criminals as a response to what's called stimulus hunger. In other words, their autonomic nervous systems are slower by default, so they want to increase that. So they do kind of risky things, right? High risk behaviors, high adrenaline behaviors. And while many of those are perfectly legal, like riding roller coasters or skydiving or, you know, just going out for a jog and running, many of them are also illegal. Committing crimes, assaulting people, burglarizing somebody's home, all kind of give these criminals that stimulus that their body is lacking because their autonomic nervous systems are much slower than the rest of us, or most of us, right? So that's one idea that's kind of been put forth. How it really works, and exactly what that mechanism looks like is still completely up in the air. Now, genetics, right? Let's look specifically at your genetic code, not just the sex chromosomes, not just your brain biology, not just your hormones. We want to look at your genetic code as a whole, right? As everybody should know watching this, you inherit kind of half your genes from your mother, half your genes from your father. You become this nice mix of their two genetic sequences, and that determines your genetic makeup, which is kind of the blueprint for how your body knows to make you, right? Now, the study of genetics and heritability began a long time ago. And how that impacts crime, right? So way back 100 plus years ago, late 19th, early 20th century, there were these two famous studies attempting to support those early biological theories of crime, right? And these two famous studies were on families called the Jukes and the Kallikaks. And the author made sure to point out that this wasn't actually their last names. They kind of, did that whole change the name to protect the innocent thing even back then. So these are fake names, but there's the Juke family and the Kallikak family. Two separate studies, and both seem to show that basically everybody in this family is a criminal of some type or another. we can trace it back generation by generation and find that, man, dang near everybody here is a criminal. But if only one parent is going to be criminal, the mother is more influential than the father, right? Now, this was kind of rejected and shown to be stupid for many of the same reasons that the early biological theories were shown to be stupid. For one thing, there were lots of things other than genetics that these families had in common. Everything from, they usually lived in the same areas, they had the same social class, very similar, if not the exact same education. All these other factors were also the same. You couldn't narrow it down to only genetics that was similar with these families. So the fact that there were a whole bunch of people in this family that were all criminal didn't mean that it was genetics that was creating them as criminals, right? So the more modern studies started looking at, they first started looking at twins, right? And there are two different kinds of twins out there. In common parlance, we call them either identical twins or fraternal twins. In a more scientific context, they're called monozygotic versus dizygotic twins. Monozygotic means they come from one zygote, meaning it's one sperm and one egg that gets fertilized, and then for some reason that splits into two different fetuses, and then we have identical twins. Then there's dizygotic twins, which are when two sperms fertilize two eggs. They just happen to be at the same time. They both grow in the womb, and then they are born and you get fraternal twins, right? So these early studies looking at twins were trying to measure concordance. Okay? And concordance is a fancy word that just means if one of the two twins is a criminal, what are the odds that the other twin is a criminal? Because if there's no if the monozygotic twins have a much higher rate of concordance than the dizygotic twins, that is indication that there is a genetic component to criminality. Because now we're kind of controlling for things like education and living situation and social class and all those things, because clearly both twins are getting the same everything, right? So the question is, do the identical twins, if one of them is a criminal, are the odds of the other twin becoming a criminal higher, lower, or the same than when we look at the dizygotic twins, the fraternal twins, right? And what they found was, indeed, the monozygotic twins did have a higher rate of concordance than the dizygotic twins. But there were associated problems with that kind of study, so that to try to get a little more accurate, they looked at adopted children, right? So what they wanted to see was, in these adoption studies, if we take a child, we take it away from its biological parents, and it's adopted into a new family, how does the criminality of the biological parent and the adoptive parent influence the criminality of the child? Because if crime is genetic, then the criminality of the biological parent should be a better predictor of criminality than the adoptive parent. But if crime is merely learned or environmental or whatever, then the criminality of the adoptive parent should be more influential than the criminality of the biological parent, right? And what they found was they're both influential. Both the biological and adoptive parents' criminality influenced and affected the criminality of the child. Interestingly, though, it seemed to be the biological parent that was slightly more influential. But one of the things that the kind of one attack on these adoption studies was children aren't given to parents randomly, right? When children are given up for adoption, the adoption agencies don't give those children to families randomly. They're kind of matched up with families based on everything from race to social class to geographic areas to all kinds of different factors. So that is going to influence how much of a kind of conclusion we can draw from that. So the next kind of big experiment or idea or study that was done with separated twins separated at birth, right? So essentially, if we have two twins that are born and then given up for adoption, and then one twin is adopted by one family and one twin is adopted by another family, now we want to see, 20, 30, 40 years later, whatever, we're going to go back and we're going to see what is the concordance rate between one twin and the other. Where really the only thing they should have in common is genetics. Their family situations are very different, their upbringings, their educations, all those things should be very, very different. The only thing they should really have in common, if they didn't even know the other existed, didn't know they had a twin, didn't talk to each other, didn't influence each other in any way, the only thing they should have in common is their genetics. And what they found was an even higher rate of concordance than those original twin studies. If one twin was a criminal, the other was even more likely to be a criminal than they were in those original twin studies that we just talked about a minute ago. So there does seem to be some kind of biological something going on. Question is what, right? And this has been looked at by evolutionary psychologists, right? So modern people who are applying this concept of evolution in a much more scientifically valid way than those early biological theorists did. And the idea here is that there is an evolutionary niche, or niche, depending on how you pronounce that word, for some members of our species to victimize others. That will help them in this evolutionary goal of reproducing, right? And obviously we don't want everybody in the species to victimize others, but there is an evolutionary benefit to having a small percentage of people who will victimize others in order to increase their reproductive advantage, right? And according to this theory, it's young adulthood when that is most likely to be beneficial, right? So you're kind of at the social and physical and emotional peak of your ability to kind of find a benefit in victimizing others. Whereas as you get older and older and older and more established, the benefits for victimizing others get less and less and less and less and less, right? Now the problem is this is inherently or very, very difficult to measure because it's impossible for anybody to measure somebody's reproductive strategy. Because that's a subconscious thing. That's not something we consciously think about, right? Our evolutionary strategy for reproduction and continuing on our genetic material and all that stuff, that's not something we can even know about ourselves. So it's not something that can be kind of directly measured or even really accurately indirectly measured by modern scientists. So until we find a way to really measure reproductive strategy that isn't just a measure of the behavior we're trying to explain, there's really no good way to test this. All right, so what is the conclusion from all these modern biological studies? Well, for one thing, most of the data from all this shows a weak relationship between any aspect of biology and criminality. It's not very strong. but it does seem to be significant, right? Statistically significant. There's something going on, but it's not a very deterministic factor, right? And the stronger the study, the better the science, the weaker that effect seems to be. Again, statistically significant, there's something going on, but it is a weak effect. So it's not just nature, it's not just nurture, it seems to be both. With nature providing kind of this probabilistic window, slightly in this direction toward criminality or slightly in this direction toward non-criminality, but there's going to be huge amounts of variation within that window based on some other factor. What those other factors are, we're going to be talking the rest of this course about it. Could be genetic, could be geographic, could be financial, could be all kinds of different things. But there's other factors that determine the variation within that rather large window, right? But the earlier we act, the earlier we can kind of identify high-risk groups versus low-risk groups, the more we have a chance to change that window, the more we have a chance to kind of attempt to get that person's criminality on the lower end of whatever their biological window seems to have created. So the more we can kind of increase interventions among children and kind of identify who's higher risk and lower risk, and then go in to the high risk ones and do something to try to shift their criminality as far into the lower end of their particular window as we can, the better. All right, but that is the end of our discussion on biological and biosocial theories. Keep in mind, I am not a biologist. I barely passed high school biology, so if I was a little bit off on the the hard science in this section, I apologize. Please do not send me hate mail about how I got this completely mischaracterized some aspect of hardcore biology. The really important thing is that, there does seem to be some kind of biological something with crime. Whether I got the genetic stuff exactly correct or not is kind of beside the point, okay? So, not a biologist. Please don't hate me. But I really appreciate you watching. I really hope you learned something, and I'll see you in the next one.